Hi guys, welcome everybody to our .NET user group. Today a little Christmassy, the last time this year. Good things coming to .NET community. We're starting a little bit of a cooperation with other user groups. So Wojtek is here today from Xamarin Meetup and .NET Days. He's the organizer of a .NET Days conference. They record .NET podcast, new episode yesterday? Today.
About compilations and IoT just in time. If you are interested, go to .NET podcast.cz.
So the podcast is .NET Podcast CZ, and the conference is .NET Days CZ. Recently, they managed to bring Scott Hanselman, the .NET rockstar here. Was here two weeks ago. So be sure to follow them as well. We're trying to get the meetups together so that you get the content, better content, more frequently, and we'll see what happens next year. Microsoft also is starting a couple of .NET Core teams here, so they have development for .NET Core in Prague. So hopefully we'll manage to bring some speakers from them as well. Today we have Dominik coming all the way from Poland and fighting Prague traffic.
Yeah, I mean, it's horrible in here. I parked once, then someone told me that I can get my car lost, so I switched the place. Now I asked you guys in here, and you told me the same. So we will see in 2 hours if I will still have my car and the transportation to home.
We'll pray for your car.
Thanks.
All right, so Dominik.
Hello everyone. First of all, thank you for letting me be here. My name is Dominik Przywara, and I wanted to welcome you everyone on my talk called Whose Task Is This? I made almost 600 kilometers, not to say that it's your task to do this and just to go home like I do in Poland, so we'll talk a little bit more about a few things. So, what's the agenda? First of all, we will start with a little bit of introduction into asynchronous programming in .NET. Then we will talk about run and forget pattern. We'll wrap some events into tasks. We will see how async operations work in lambdas and what this brings to us. What is ConfigureAwait, ValueTask, task aggregations, cancellation token, dealing with exceptions, and lots of examples. First of all, this presentation is public on my GitHub. You will see the link in the very end, so also the demos will be there. So why should we even bother? First of all, we don't want to waste our time to things that don't really matter for us, or the things that take a lot of time. Do you know this? When you are using Windows, for example, or Android, your app is not responding for a few seconds, then it's all white, or just you have the prompt, kill your app. It's because you're taking too much work on your main thread. The main thread is the thread that you're starting your application with. I will call it also UI thread because I was, let's say, born in mobile world, so for me it's an UI thread. Everything that has to deal with the UI is on the UI thread. So if we don't want to waste our time on things that doesn't matter for us, and we don't want to bother our user with it, or things that need a lot of time, and we want to just push the job background. Thanks to that, we can give better user experience for our users. The tree is falling down. So no more freezing UI, no more prompts about killing our application. How awesome is that? And we will be able to prevent operating systems from killing our apps. Do you know what Linux, the most stable and the best OS ever, does with your application if the watchdog cannot reach it? It doesn't ask, it just kills it. It's just, Windows at least has the courtesy to ask you if you want to kill your app, and he gives you the knife to kill it. So, you know. Yeah, so over the years we had 3 asynchronous programming paradigms in .NET. First of all, there was APM, The interface called async result with methods begin and end. It's deprecated, and if someone still has to deal with it, I can hug him later, because I'm really, really sorry for him. So we don't want to think about that. The next one was event-based asynchronous programming. I put asterisk on deprecated because we cannot get rid of it. We will still live with it, but it's somehow it's some kind of asynchronous programming paradigm in .NET. And the latest since .NET 4.0, task-based asynchronous programming, or better called TPL, Task Parallel Library. So the thing you have to take from this slide is that it's a very, very mature thing in .NET. I mean, asynchronous programming is very mature, so if someone tells you that he will not use all these async awaits because he doesn't trust them and it doesn't even work, it's him that doesn't understand the thing. It works perfectly fine, and it's very, very old technology already. So let's go with some basics. There are two types of asynchronous operations. First one is IO bound, input-output operations, and the second one is CPU bound. So in the first one, we don't need real threads to work to get our job done. On the second hand, we are taking our CPU time. I will show you in a few minutes. Basically, it's a promise that the job will be done in the future, something like in, let's say, JavaScript. Everyone hates it, but you know, the promises are just perfectly the same. And maybe surprise for someone, but async keyword in your method declaration does not make your method asynchronous. You know, you can return, you can make a declaration like public async task of int a and return 4. It won't be asynchronous. It will be perfectly synchronous code. And I have a little warning mark in here. The async method lacks await operators. So it will be executed synchronously. And that's the keyword that does all the magic, at least most of it. Your methods are being asynchronous when the await keyword appears. Not all the time, but most of the time. We can, let's say, return or use return types with keyword async like void task and task of t. I don't know where's the t, but it's a generic one. And the await keyword yields the control back to its caller. I will show you this in a few minutes in a demo, but basically if you hit the await keyword, you yield the control back. I will show you how it works. Very, very, very important thing is that console applications and ASP.NET Core, only ASP.NET Core, do not have by default synchronization context, and you don't want to bring one to them also. And it's, let's say, saving our assets, sorry for the language. In a few cases, we cannot deadlock our applications, like we can in Xamarin applications, classical .NET Framework Web APIs, WPF, what more we have? Uno, UWP, whatever. So synchronization context is a thing. I will show you how to deadlock your application in a few minutes. Task is a reference type, so we have a cost of it. When we are using task type, we have garbage collection in it, kicking back. So you have to remember about it. We can shortcut it. I will show you how, but it's not so nice at all. And also, I will not tell you about it in details. I encourage you, there are great talks on YouTube if you want to, or you can decompile your code if you want to. Basically, asynchronous programming relies on state machine in .NET. There's a huge state machine that just tries to juggle with your threads and when what ends. I won't discuss it because we have to talk like for an hour, so more. Okay, yielding control to caller. What do I mean by that? We have simple console applications. Sorry, I'm turning back. So here we have a simple console application. We have some async delayer class. I will show you in details what it does. console helper that will print our messages in different colors. Here we are waiting for 150 milliseconds, and we are starting our delay for a second delay from async delayer. Async delayer has, oops, I hope the screen is well. Async delayer has private field called task and the method. The method checks if the task is not null and if it's completed. If it's null or it's completed, then we will print out in red create task, wait for a 1 second, assign the task delay of 1 second to our variable, await it, and then when it's done, we will print out in green that it's done. And I'm not placing in here await because I want to show you that it has its point. Everyone sees the bottom? Not this project, not this project, not. Yeah, so I will be like that. I will kneel for you right now, but wait a second. Okay, this didn't help me at all. Come on. Bonus will be if we will have some time. Yielding. Okay. It's not huge, so you should see there are three different colors. We have the yellow one, the green one, and the red one. So, loop like this works in every single application that's window-based. Have you ever had the pleasure of working with a WinAPI? Nope. Yeah, perfect thing, perfect time. So you had this control loop where you had to deal with your keyboard, with your mouse input, with everything. And all applications works the same. You have one main loop that works, coordinates everything, and this is exactly what it does. So now, as you can see, if I would place await in here, it would just wait for 1 second and do nothing. Then if the await would, the instruction inside would complete, then it would resume. But what happened in here? So we have no task already, or it's completed, in its completed state, yeah? So we are creating new task and we are hitting await keyword. When we hit the await keyword, the application returned yielded the control to its caller. So the program CS is the program class. As you can see, we don't have await keyword in here, so it doesn't have a place to hook into. So it's just executing the code on and on again. If we would have await in here, it would wait and yield the control one level above, so to the task main method. And if there's an await keyword in there, it would wait. If there was not, it would just run in a loop. Everyone okay with that? I hope I explained it good enough. If you have questions, just ask.
Can I explain one more?
Once more. Okay. So basically, if you have you have execution path, yeah, in your application. Let's say we are going from top to bottom.
Now, does the method color message does?
Once again, sorry.
The method, the color message. What's inside?
Colorful message.
Colorful message.
Oh, there's nothing. We are just changing the color of foreground. So the word in here would be in green. That's greenish, let's say. Yellow or red one. That's all it does. But if you have execution path in your application, let's say your operating system is starting this class. So OS will seek for a main method. So it's common for every single language you use. Then you have this instantiation and while loop. Right here we are awaiting for 150 milliseconds, so you will be able to see what's happening in the console, because it can print very, very fast. So the moment you hit await keyword, the control is yielded one level above. So you don't see anything above in here, but there's a code running your console application. And if there will be a wait for your main method in there, it will wait for 150 milliseconds. If not, it will go down. So the same, it will go to the next instruction. We have the while true loop, so it's never-ending loop. So the moment we are getting into this method, and there is no task or it's completed, we are printing into using red color and starting new task. Then we hit await keyword. So we have to once again yield the control level up and check if there's a wait. There's no await in here, so we are not waiting with it. We are not yielding it once again, so the main method will be controlled by the host. We are just executing next line of code. Okay? Simply enough?
It's better.
Okay. Perfect. So, slideshow, and it will go. Yay! It's good. So the conclusion is you have to await fast. The sooner you hit the await keyword, the sooner you are able to bring all asynchronicity into your application. Because everything before you hit the await keyword is executed synchronously, line by line. So if you will have, let's say, a synchronous method, and the await keyword will be the last one, and you will have 100 lines above it, it will execute 100 lines, and then it will see that you have some asynchronous operation. Let's say it's asynchronous, because it's a white lie. Why it's a white lie? Because if you would decompile your code, you would see that state machine, first of all, checks if there's a result already cached in. If you have to create all this stack, because it's not cheap. You have to allocate 1 megabyte of stack to run a synchronous operation in your code. So it's very, very expensive. But you have to remember that if you want to leverage the asynchronous models in your applications, you have to await as fast as you can. Okay. So you know how to go asynchronous, but you will also find some trolls, maybe in your team, maybe you will be the one troll, that will want to bring asynchronous methods to synchronous execution. And it's the worst idea ever. Trust me, you don't want to do that. Everyone will say that sync over async, so trying to synchronize your asynchronous operation is a bad idea. Also, you should avoid using dot result, methods get awaited, get result, method wait, or wrapping every one of those and one by one into task run. It's a bad idea. If you can use a synchronous method, you should use a synchronous method. Okay? Perfect. So, can someone tell me to what we will bound the operation on the left? CPU or I/O? Why? Because we have HTTP client on the right side. Yeah, and that's true. And the thing you have to remember, it's every time you execute. Sorry, it was on the right side. Last time I was talking about it. If you run method task.run, you will use a thread from your thread pool. If you will use parallel linku, plinku, in your code, it will also execute it will be also executed in a CPU bounded manner. So it will take threads from your application. You have to remember when you are using, for example, ASP.NET Core or just ASP.NET whatsoever, every single request is a new thread from thread pool. So you don't want to cause something called thread starvation. The moment your application has no available threads in your thread pool that can work and do the job for you. So you have to be very, very careful when you are trying to take a thread from your thread pool. Also, if you are having I/O-bounded operations, you don't need thread at all. Seriously, you don't need thread at all. There's a one thread running in a .NET runtime that will take care of every single callback from the operating system that your I/O operation has finished. If you will ever see something like, I don't know, asynchronous read from your hard drive, bullshit. There's no such a thing. Everything on the driver level is synchronous. You have only one needle in your HDD. If you have SSDs, yeah, it might be better, but we are talking about HDD in here. If you're executing code, for example, we are using HTTP client and we want to make a HTTP request. We are just telling our network interface that, hey, I want to download all you can from this website. And then we can go to our code, execute it in the old manner, and the moment the network card will be ready and will download everything it can to its buffer, it will tell us, hey, I'm ready. Come on and pick your stuff, mate. Okay? So I/O-bound operations do not need thread from a thread pool. And if you want to play with it, you can. You can try it out in your code. Okay. One more thing. It should be area, but if you want to be a very nice guy and return task everywhere, I mean, I know I cannot use synchronous code anymore, it's passé, so I will be asynchronous. But I have to return just a value, simple synchronous execution, and I just want to wrap it in a task. It's the worst idea ever to put a value into task.run because you are taking a thread from a thread pool. Better way to do this is to use method called task_from_result. Not the best one, but it's a better one. Why it's a better one? Because if you will be lucky, you will have cached task results from .NET runtime. For example, for Boolean, you have only two values. So if you will return task from result true, it will just reuse your cache. That's it. No allocation at all. With GUI, it will be more painful, but whatever. The best idea here is to return ValueTask. ValueTask is a struct. It was created especially for things like asynchronous stream operations. So basically, if you have synchronous path, you will use ValueTask to return. It just wraps task into a struct, so you have no allocation on your heap. It's just on your stack. So you don't have to garbage collect it later. It's not like we should just throw it all and use ValueTask since now, forever. Nope. The problem is if you will have asynchronous code and you want to return ValueTask, you will allocate twice. So you only should use it when it's synchronous and you want to return a result in a, let's say, asynchronous manner, okay? Yeah. And one more thing, you have to avoid using task.run in your public APIs like, I don't know, NuGet library. Or at least if you do, please document it very, very well. Why? Because I had a situation myself. We had this brave junior, it might be me, shouldn't, maybe not. But there was someone that tried to optimize the way library worked. And we saw that it returned a task. So we just run all, instead of awaiting one by one, we run the loop like hell for 40,000 times, put everything into, let's say, array, use aggregation to await for everything, and the library used task.run. 3 requests for a, let's say, bigger computation, and our API is not responsive. Why? Because someone in the library thought it might be a great idea to put its code into task.run. So we were not aware of it that some guy trying to be clever stole all threads from a thread pool. And our API was just not working. So if you're trying to steal someone's thread from thread pool, please document it very, very well, okay? Yeah. Do you need some break? No, it's perfect. Next. Okay, background jobs. If you want to make a background job in your application, let's say you will process a queue in some weird manner. Please avoid using task.run because you will steal the thread from thread pool from yourself. So it's also not a good idea. It's better to spawn new thread that is designed only for the job you want to do. Okay?
It's a good idea. It would be much better to take it from that pool and save some creation.
If it will be long-lasting thread, it's a better idea to start it this way instead of this way, because
What does it mean, long?
Long running, for example, I don't know, if you would have a queue processor, it would run all the time. I mean, you would just instantiate it once and put messages into it. Yeah. And the thread pool is shared across everyone. So your ASP.NET Core application will use the thread pool on the left side. If you want to use thread that it's outside of the thread pool, you use just new thread. Yeah,
that's obvious.
Yeah, that's obvious. So it's always also if it will be, for example, longer than a second, it's better to start new thread, because the API might be on the heavy load and you will have also thread starvation, because it's a shared resource. And don't forget to put is background true, because you will be able, thanks to that, to exit your application while the thread is running gracefully, not like stabbing it into back. Okay? Run and forget. So this was the basics, and now it will be just fine. Someone is able to tell me what's wrong with this code? Yeah. I don't want to sit down here, but I will try to do it so. Okay? Is it better? No, it's not better.
It's a fine task.
Okay.
And it's not awaited.
And awaited.
Yep. So in most common scenario, you will have dialogue with nothing in there. Okay. So and there's one caveat for that. If you will have exception in here, it will crash your application. It will crash your process without knowing it. So for example, you can try it out in your ASP.NET Core application, do something like that, crash your application. The app will be running, but you will be unable to get any request into it. Okay? It's better to just change it to task, await it in a proper way, and here, all exceptions that will be thrown in this method, inside of it, will be caught into task schedule unobserved task exception. You won't see it straight away. First of all, it has to be collected by GC, so you can play it naughty and use GC collect, GC wait for pending finalizers. Once again, GC collect, so you will have everything from the finalizer queue back to being able to collect, and you will see it there. Yeah. And the only moment in your life let's say you can use async void is in events like methods. Event like method, it's just normal event handler event, you know, and you cannot change it because it's the way the runtime is created, so you have to use it this way. Okay, but never ever try to use async voids. it can be pain in your buttocks. Okay, so let's wrap it into event. We have our favorite song player that is instantiated using song and player. How convenient. We have event onCompleted. We are subscribing to it, and we are starting our favorite song. Then we want to show the dialogue. The issue, first one. Every time we will play the favorite song, we will subscribe. So we will see first time 1 dialogue, 2 dialogues, 3 dialogues, you know, because you are subscribing more, and you are not unsubscribing. Second thing, you are unable to tell anyone that your song has finished playing because the event is inside of the player. You are wrapping it in here. To do it, you would have to create once again event handler, provide the possibility for others to make memory leaks once again, to make weird bugs with multiple dialogues and so on. So it's not a greatest idea. I mean, you can work it around, or you can be over-engineering guy and use tasks. Why tasks? Because those are fancy ones, and you won't have to think too much about leaking memory. So, to achieve it, first of all, if we want to wrap our event into task, we are creating instance of a task completion source. Very, very important thing. You have to pass the parameter task creation options, run continuations asynchronously. There's a small thing in the runtime that will change the behavior of your asynchronous operations, that they will be synchronous after you will hit the completion of task completion source. So everything after will be synchronous in your request, for example. So you have to always put the run continuations asynchronously into task completion source. Then we are creating a registration variable of type cancellation token registration, and there is a cancellation token passed into it. The one more thing we can do instead, opposed to this, is we can stop playing the song in a better way by using cancellation tokens. Okay? Those are very fancy ones. Have you ever tried to use one? Nice. I mean, once I had 40 people and no one knew what cancellation token is. So I mean, massive. Okay, so we have to check if the cancellation token can be cancelled and then register what we want to do later. We can cancel after a few seconds or just register. It's the thing that will be executed the moment you will try to cancel everything using this cancellation token. The fun part is you can reuse the cancellation token in multiple ways. So with one cancellation token, you can kill, for example, 5 players or 5 HTTP requests all at once. It's a very, very useful thing. So we are passing what we want to do on what object. Then we are subscribing to our onCompleted event, starting it, and returning a task. So since now on, everyone that uses this method can just know if we stopped playing the favorite song from our boss, okay? It's easier to manage using tasks instead of using events, especially if you have a chain of events. It's just hell in one moment, so it's better to use tasks. And here we have a method that is subscribed to onCompleted. First of all, we have to dispose our registration token. We are disposing it, we are unsubscribing our method, so we don't have a memory leak, we don't have weird behaviors anymore. Then if we want to, then we can, or both, try to set the result to true or false in this example because we are returning task of Boolean. Or we can set it into cancelled state, or we can set it into exception state. The one thing is you have to remember that if you are setting the task to cancelled state, or someone will ever somewhere, you will have an exception. Because there's an exception thrown in the moment you are cancelling execution of your tasks. So be aware of it, okay? You have to catch it. You should catch every single one, but we will talk about it later. Okay, context matters. We can see that to an action which is void underneath, we can assign something like some lambda like that, and the same we can assign to function of a task. So let's say lambda that returns a task. Can someone answer which one of those will be resolved in here? Because it's totally the same lambda. And I can use it either on void or a func of task, you know?
What's the question? Which of them will be used?
Which one will be used in here? T1 or A1? Bless you.
T1.
Right?
I'm just trying.
Yeah, it will be T1. Guys in Redmond are quite clever, or in Prague right now because they're opening positions in Microsoft for .NET team. So Microsoft have some clever guys. So every time it can use task, it will use task because it's better behavior for you. If they would use an A1 in here, so action, so void, you will have a lot of weird behaviors later. Okay, so now we know every time we are trying to pass some lambda into our task.run method, it will be func of task, okay? Quite simple. So let's say we have two methods. Some action that after 2 seconds will write that it's completed, and we have some dispatcher. The dispatcher is a custom one. Also, the dispatcher takes a delegate. So we are passing the same. It should be, for example, the T1 as we saw earlier. So we would have execution path like some action completed, exception have been thrown. Okay. And if we will run this piece of code, it might end like this. Why? There was a bug in UWP that worked exactly the same way. They didn't want to pass just ordinary function of a task. They wanted to pass delegate in there. And the delegate had void in it. It wasn't a task. So even though you awaited everything, it looked like it should work, it didn't. Because someone messed up in here. It will be easier maybe like that for a few minutes. Just change it to task and everything works. You have to be careful. If there's a delegate, I mean not explicitly an action, function of a task or whatever, you have to check what the delegate type is. If it's void, well, it won't be easy. If it's task, you are free. You're good to go. Okay. I told you that there will be a lot of examples. I have some in also in the background. So, ConfigureAwait false. Does someone know what it does? Perfect. 2, 3, 4, 5. Let's say 10. You know how your code will look like when you will compile it? From this little monster with only 4 lines of code, you will have something like this. Also, there will be a state machine, which I won't explain to you because I have not enough wall in here. So, if you will have the default behavior of ConfigureAwait, which is true, you will have something like that beneath your after you compile your code. So, the synchronization context will be captured into variable. Then your await method will be transformed into continue with. Then on a context that it was captured earlier, so after the download config was completed, we will post an event, a message to our synchronization context that was captured with another method. And it will go on and on and on. The problem? We will try to synchronize our code to the synchronization context that we came out of. And it's quite good when you are trying to manipulate, let's say, UI thread or main thread in your Android application, iOS application, while using Xamarin, basically. But it's a bad one if you want to run your app in a very, very performant way. So to do it better, you should all the time use something like ConfigureAwait false. It looks ugly as hell, I know. And the good part is, as you saw in the very beginning, in console applications and now in ASP.NET Core application, you have no synchronization context. So you don't have to deal with this. You won't get by default performance penalty because you have to execute more lines of code beneath, so it's a performance penalty always. And you don't have to have ugly code. But if you are using libraries, if you are creating libraries, and someone will reuse your library, let's say in his or her Xamarin application, the moment they hit the ConfigureAwait and they try to manipulate the UI, magic happens, application breaks. So if you are certain that you don't have to manipulate UI thread, you don't need to capture the synchronization context, because security context there will be always. There's one more, but you have to read about it, and the page that describes how it works says in the very first line, if you are here and you are reading why this works, you really have to rethink what you've done with it. So you don't want to know too much about it, but you don't have to use this if in ASP.NET Core applications. In every other application like ASP.NET on a .NET Framework, Xamarin, you have to. As long as you don't need the synchronization, so you don't have to manipulate something from the original thread.
I think that ASP.NET Core on .NET Framework doesn't have authorization context too.
Doesn't, because it's on the level of ASP.NET, yes.
Yeah, but as you said, the compilation, so if there is no
synchronization context, yes.
This doesn't happen.
It just doesn't capture the value. So it won't try to put everything on the previous context that it captured. It will just it will just have those continue with methods. So it will be scrapped of this one.
So it will simplify even this compilation.
Yes, yes, and that's why it's you have no performance penalty because of it. And most of the time you don't need it, to be honest. Okay. Eliding await, a.k.a. state machine shortcutting. Well, does anyone know what this brings to us and what this does? Let's say, yeah.
The first doesn't wait. It's like just.
And there's one more thing. You don't have state machine in here. If you have await, you have state machine. So you have more code. So you are allocating 1 megabyte of memory on your stack. And most of the time you don't bother. And there was one beautiful day. The first time I gave this presentation, I was using MacBook. Oh, God damn it. And I wrote something like that to show an example. of Eliding using HTTP client. There's a new syntax, so there will be mustaches in here, let's say. And once I returned a weighted value, and once just a task. You know what will happen in the second one?
Dispose.
Yes, it will enter dispose. And usually, it should, yeah? And I was talking, showing this to people, and a friend of mine just came to me and he's like, no way it will work. I know it shouldn't. Take a look, my friend. It works. No way it won't. Till the day .NET 5 will come, and we will have one runtime to run the whole. You have multiple different runtimes. This one is a dispose method of HTTP client in a .NET Core FX library. It has pending request cancellation token source.cancel.dispose. Quite nice, isn't it? And here you have a mono runtime. The same class, HTTP client, the same method dispose. If disposing, cancellation token source dispose. One thing is missing, isn't it? On Windows, the behavior you got by default was canceling all the requests you've made. And it was the correct one. On mono runtime, the request was just going on. And the behavior was very, very unexpected. So you have to remember that implementation can differ from runtime to runtime. I am a mono contributor with 2 lines of code. Never managed to compile it my own, but now it works fine. But they've been missing just this one goddamn line that was canceling all the requests going. And I was poor guy with a MacBook, so. You want to see how to declog your app? Is there someone that uses WPF, UWP, Xamarin, ASP.NET, not Core? Yes? So it will be at least for you, mate. It's very easy. Whoa, whoa, whoa. Why are you yelling at me, mate? Deadlock. Very, very, very simple. Oh, I have some... Okay, with the dispatcher tests, but never mind. We have home controller. And we will do something like that. In the moment when we will hit that... Oh, sorry guys, it's too small, sorry. Looks fine in here. Come on. Better? I hope. So, we want to render a view in classical ASP.NET MVC 5 application running on .NET Framework. And there is this page you get when you create your application. You can have your About page. You just have to click it. So what I will do in here is create some asynchronous operation that will await for 1 second and then return the description that I will assign to my viewback message. Nothing fancy in here. But I am a grumpy guy, so I don't believe in asynchronous operations, so I want to have it synchronized. Let's see what happens. And I will explain to you why in a second. The big question is where it will open. Oh, it's here, so it's perfect. Come on. Come on, mate. Okay, so you see, I can open the Contact tab, the Home tab, and if I will hit the deadlock button, it's trying to render the About page. And as you can see in here, it's just spinning and spinning and spinning. Why does it has to be like that? And why it's a thread in every single application, including simple web API. Web API using .NET Framework. In this moment, I'm telling the compiler that, hey, this synchronization context will be mine. And the compiler says, okay, here you have your synchronization context. Then I run my application. Of course, it happens. I'm yielding the control because I hit await button, await keyword. And after 1 second, this task delayed method comes, hey, I'm done. Give me synchronization context, mate. This guy in here says no. But I want one, no. Come, no. And in your applications, in your web APIs, after, let's say, 20 requests, 40 maybe, your application is dead. You have no threads to work with. Everything is blocked. The only solution? Restarting your applications. That's why we don't have synchronization context by default in ASP.NET Core, to avoid such a situations. Okay? You can do this both ways. Yeah, okay, mate. ConfigureAwait false will say, I don't need synchronization context in here, go on. And it will execute just fine. But it's not the nicest way because I told you that you cannot use result, get awaiter, get result, or wait. So all you should do is just change this goddamn method to task. Yeah, avviato. And it will work. Okay? Asynchronous operations are fine, and you should live with those. Really. Okay. Please let it be the right. Yes, yes, it was the right shortcut. Value tasks. Once again, nothing's for free. I told a little bit more earlier in the very beginning. If you have synchronous path and you want to return task-based something, use ValueTask. If you have asynchronous path in there, you will be penalized twice because you will have to allocate twice, and it will be much worse for you. It might change thanks to this pull request on core CLR. They are trying to make methods using ValueTask and ValueTask of T that those are allocation free. So basically, there may be a chance that they will bring it even more, and they will have this allocation free everything and not double penalize. But most of the time, if you're not writing high performance frameworks with synchronous paths, you don't use value tasks. I know those are fancy ones, but always remember, if you want to have some performance gains, you have to measure. You have to measure time, you have to measure memory pressure, everything. And you will see that not all the time it works the way you want it to work.
So the value task, what if I have a factor A?
Yep.
And there is 5 options where I just turn from result and 1 when I need to get some data from database. It's a good idea to use value task in this case?
As long as you have a very rare way to hit it will be the coolest path ever to hit the database. If you are hitting it quite often, you will be penalized, so it's not worth it. But to answer the question the proper way, measure it.
Sorry?
Measure it.
Yeah, okay.
It's the best way, because if you want to gain some performance, you have to measure always. And it might not be, and it might look better, but in the end it might just be even worse, because you have to remember to check the memory pressure, because it will be faster in execution maybe sometimes, but you will have a lot more on your GC stuff. So you have to remember about this. Okay. There is a reason why the top one is bigger and the bottom one is smaller. Those are synchronous. You just forget about those. Always use those. Okay? you don't want to synchronize your code. I've shown you that it's a bad way. If you would, someone uses per view in here? Magnificent tool. I mean, seriously, if you know how to use it, it's magnificent, but I don't know how. You will see in what state your thread is when you hit the result. It's blocked. And the core dump for CPU is also much more expensive than suspended one because of awaiting, okay? So you play with it, you will see. And if you have multiple tasks and you want to all of them to end up in the same moment, I mean, you want to execute your code when every single one of tasks you've passed in finishes, use task.whenAll and pass the tasks inside. If you want just one of those finished and just go with it, when any, the same with sync, but don't remember about the sync. I just tell you that it is, you have to forget about it. You don't want to use it. Execution would look just like this. Create a list, array, whatever, pass it into whenAll method, await it, and everything beneath it will execute when all of those tasks will be finished. And you have parallelized 4 requests. So if you would have await, you would wait the sum of all requests. If you use this, you have the time of the longest request. Okay? So it's a small gain. If you want to let the fastest win, I mean, for example, you are creating stock exchange application and you need the first stock that responds to you to be very fast. You are creating 4 tasks, wait for any of those and cancel others using cancellation token source. One thing, it's disposable, so remember to use using. In C#8 it's very, very nice, so just you don't have to use the mustaches like here. I don't know, I don't remember the word, sorry, it will be mustaches. Curly brackets, thank you very much. And it's not a mistake that I await here twice, because task when any on await returns the task that finished the first. And if you want to unwrap it to the value, you have to await it twice, okay?
But this is the place where the result will be fine. Dot result.
Yeah, because you awaited first.
Yeah.
But, you know, it's better not to show others that, well, you can use result if, no, you don't. Just leave it, mate, you don't.
It doesn't exist.
Yeah, it doesn't exist, like the synchronous methods. I never shown you before, you know? I mean, nah, just don't. If you want to hack, I mean, you shouldn't because it has a penalty. If you have an API that doesn't allow you to use it to pass cancellation token inside, and you want to cancel the request, cancel after a few seconds, for example, you can always run a new task. You will use in here task completion source of some type. And once again, remember to pass in the run continuations asynchronously. You would create a cancellation token source that will cancel after a few seconds and will try to set the state of the completed task to cancelled. Then you are executing this line when any of those. So let's say 5 seconds. If in the period of time of 5 seconds the original download config would be downloaded, then in here we will be completed, then we will get it in here, we will set result to null on the other one. Why we don't want to throw the exception? Because if you set cancelled, there's exception, okay? And return the value. Using await the result. But if in the period of time of 5 seconds it won't finish, you will have executed this lambda that will try to set cancelled state on the task completion source in here. So there will be exception thrown. The problem is you cannot cancel this download config. it will just run forever. Let's say 30 seconds because of the timeouts, okay? But you can hack it. If you really need it, you can use it, but I don't encourage you.
And does this really compile? Because
Yes.
TCS.task is typed to task, not task config.
Yes, because this one is just task completion. It has a field task in it, and we are never returning it. As you can see, we are never returning the TCS. In here, we are just trying to set the result to null, not to throw the exception, and we return the completed task that is the download config in here. Because if the download config will be not fast enough to complete itself, there will be cancellation thrown. And we will ignore just everything that happens in here.
Yeah, I get it, but I cannot add a task into a list of task conflicts.
TCS.task.
Because it's typed on the first line, it receives config maybe.
Yeah, yeah. You have
Oh, okay,
in here. Yeah. Oh, sorry. I thought I mentioned it. Well, yeah. Okay. I have some examples also, so we will try to run on those. The saddest part is that exceptions are thrown where the await keyword appears. So basically, if you want to manage all your methods, you should wrap every single await keyword into try-catch clauses. It kind of stinks. So yeah, whatever. But if we are running aggregates, if there will be exception, then when you will use the wait method, you will have aggregate exception. In the synchronous path, you will have thrown aggregate exception if there will be any exceptions in the array in here, okay? And you forget about this because all you will use is when all, and then you will have first exception thrown. First exception that will be thrown in here, in this whole pack of 3 downloads, will be caught in here. I will show you example in a second. In my IDE. And then if you want to get every exception that appeared in your system, you have to cast the task exception as aggregate exception and get inner exceptions. Okay? It's not the nicest way to deal with it, but it's something. I mean, have you ever heard about exception dispatch info? There's a class, exception dispatch info, that was created to deal with exceptions in try clause, because the moment you unwrap the exception and do something with it, you cannot rethrow it with all the stack and all the information you gather in your exception. So you have something like exception dispatch info, you can reuse it to rethrow the exceptions, but yeah, that's the topic not for today. And I will show you something in here, because it will be easier for you. Yeah. I know it's a lot. Exceptions. So we have this class called exceptions and 3 methods, download A, B, and C. One waits for 1 second, 1.2, 1.6 seconds. 2 types of exception and 1 argument exception. And now if I will run my unit test, so in wait, I will expect the aggregate exception to be thrown. Yeah. Where are you, mate? Where are you? Wait. Oh, yes, it's here. So you always get what you want. No, you don't. I mean, seriously, this is how it works. 2 seconds, and it was longer. So, if you are using wait, there will be aggregate exception. And to get into others, you have to use inner exceptions, and you will get all of those. But if you will use when all, the first exception that was in the collection will be thrown. So, yeah, I mean, tests should be very fast and efficient, don't they? Then, as you can see, only one method, download have thrown the argument exception. If you want others, you have to cast from the task that is returned from when all. You have to cast the property exception as aggregate exception, and then you can get inner exceptions and work with it the same way you would work in synchronous paths. Okay? Perfect. And we have eliding. Eliding is also very nice. It's very nice to have performance gains, isn't it? For free. And this one is the best one because we have no state machine. So 1 megabyte of stack memory is for us. But there is a problem. As you can see, the methods all changed is that we throw an exception a line above. So let's say in an execution path, it changes nothing, doesn't it? Because we never hit the await keyword and we never hit the return keyword. Okay? Fucking what? Okay, sorry for that. There should be slide, but there's not, so you will see a demo in here. So we have eliding, and there's a information that we are starting method without eliding. So we are using without eliding, we are using the await keyword. We are not shortcutting the state machine, okay? And if we will run something like that, we would expect, because everything is captured on the await keyword, as I shown you a few seconds ago, we expect that it will be starting without eliding. I don't really care because await is later, and then the message from inside. And if we will run method like this, it will look just like I told you. Yeah, I'm trying. Yeah, okay. You see it not? What the? Sorry. So I'm talking to you and no one yells at me. That's weird. Okay, once again, we are expecting to see the starting without eliding. Then I don't really care because await is later, and the message from the exception, don't we? And we get it. We use the method with await keyword in it, okay? And what happens in here? The method is exactly the same. The awaits are in exactly the same places, but we are eliding await inside. And if I will run this one, come on, mate. If I'm going to run this one, I will never see that I don't really care because await is later. And I will also lose my stack trace. So if you have really hot paths and you don't want to create a state machine, it's perfectly fine to elide. But in most scenarios, you don't want to. It's better for you to have this await keyword in your code. So you have this state machine because, first of all, you lose all your stack on exceptions. The exceptions are thrown not in the place where the await keyword appears, but in the place where you assign the value, because there is no implicit asynchronousy in your code later. And as you saw in the HTTP client example on Mono, it can just be weird sometimes, okay?
I run some benchmarking. We had the same discussion in our team. And I ran some benchmarks, and without eliding and eliding, it was like no difference at all. Like in 100,000 rounds, it was unmeasurable.
But it's memory penalty more.
And the benchmark.
Yeah. But I mean, it's in a really hot paths. I mean, you shouldn't use it. I mean, you shouldn't because it has more cons than pros for you. And I know it's small, but sometimes the smallest changes can,
Okay, I'm just
Yeah.
just checking because our conclusion was it's not worth it. Let's
Totally.
always have complete call stack.
Totally. I agree with you. I had once application, demo application. It had, a ton of. It was Xamarin application for Android on tablet, and it had a lot of different animations and so on. And I was in a place that I had one method because calling another method was too expensive for animations. It was just, we knew that it's to throw out the application, but it has a penalty. I was making a benchmark last few days ago. If you have inline everything, if you have these private methods inside methods, I was sure that it will just copy the code and repaste it. No, there's a call, but it's a very local call, so you don't get a lot of penalty, and calling simple method will be even more expensive. So, the small things. Yeah. Okay. Someone has a question to that? Because I know it's counterintuitive most of the time. If not, we are heading to the summary. You have to know what you're doing with wait family. You have to forget about wait result, get await get result. You don't need those. You can live with awaits. Lack of cancellation token is not a problem. We can hack it, whatever, context matters. Or if you're passing delegates inside and there is a delegate tag, not explicit action or a function, then you have to be very careful. ConfigureAwait false you use everywhere you can, but you have to remember what it brings to you. Await as fast as you can. Exceptions are aggregated. Avoid task.run because it bites mine, buttocks. And I know it the hard way, and it's awesome. So I encourage you to deep dive into it. And if we have 5 minutes, and you want to, I can show you some bonus. How to become the most hated person in a room. Seriously. So.
I'm nature at this.
Yeah.
That's true.
Let's say we create a new object of type object. Okay? And we want to await it. Who does that? All you have to do is 2 things. First of all, you create class for notify completion that implements iNotify completion interface. It has this very nice method on completed and continuation. We will run the continuation. You can use it in a much nicer way. For example, let's say buttons, but I will show you later. And we are creating the extension to our object. Object notify completion. Get a waiter. Check. Compiler still says that you cannot await object. So I say, okay, wait a second, mate. No, it's not the result, sorry. Is completed. You can now await it. You see? I can compile it, but 1 second more. We will see something, we will set something like that. Let's say and I have to, sorry, because I don't know all the shortcuts, I just switched to it from the Visual Studio and the bonus. Come on. We have before await, inside await, and after await. You can use it in a very clever way. For example, create class called, let's say, button, and you want await button. Why would you like to await button? Well, I want to click it. All I want to do with the button is to click it, you know. The one red pointless button, you shouldn't click it, I want to click it. And all you have to remember that most of the features of the C# language itself is just hacking the way it compiles. So await keyword will be the continue with method that captures the synchronization context, and it will use in a state machine get await or get result. Also, it will use the property is completed. We are having here false. So there's the thing I told you that it might go asynchronously, but it will first check if there's a result already. Because if I will set this property to true, and in get result place something else, and I shouldn't show you that because I've not tested it, but it should work. Get result. And then we shouldn't see inside await, we should see get result. Please. Yeah. It shortcutted it. There's a method, get result, and if the is completed property is already true, it will go to the method get result because we have cached it earlier in the past. If we have it false, it will go to the uncompleted method because, well, obviously we have something asynchronous to do, don't we? And then it will set the is completed property to true and execute the continuation. Okay? So, without further ado, some useful tools like async extensions for tasks and missing await analyzer from a guy called, I forgot his name. It was one of the guys that created the TPL library, so very nice. If you want to learn more about ValueTasks, go in here, it's very nice. Also the issue I shown you earlier, ASP.NET Core diagnostic scenarios from David Fowler, the guy that's standing behind the ASP.NET Core. Really nice. Stephen Cleary's blog, I highly recommend it to you because it's the guy that created the asynchronous programming cookbook for C#. It's called something like that. And of course C# docs because those are awesome. My name is Dominik Przywara. I'm a lead software engineer at Soprasteria, co-founder of Silesian Microsoft User Group, something like you, but in Poland. And here's my GitHub. Okay, so I will have one more link to GitHub with the presentation and examples. My child asks you if you have any questions. I mean, I didn't want a cat, my fiance wanted one, we have two now. So. Can I ask you something?
So I have a question.
Yeah.
Assume we have a CPU bound async
Mm-hmm.
instance. Do we have guarantees that it will be executed using thread pool thread? Cannot be executed with user interface thread? If you're having CPU-bounded operations and you're creating task using task.run method, it will most always go to another thread, or if it will be extra short, because if you will see any example with await task delay, no one uses delay 1, delay 2, or 10. All people use at least 20 milliseconds because there's a short period of time that compiler thinks, okay, it's not beneficial for me to create another thread for it or take the thread from the thread pool, so I will execute it in line. But it's very rare. If you are using task.run method, you have 100% guarantee that you will get another thread from a thread pool to execute your code. But how compiler could know how much time it will take to execute?
It just checks the classical static analysis.
For instance, if I call some
external library methods.
Then it will be unable to resolve it, and it will just throw you a new thread.
So we have a chance it will be executed with user interface thread.
Not I'm aware of. I mean, if you're using method called, task factory, if you are using, for example, task factory start new, there are options you can pass, and maybe there's something you can play with around to get it on the original thread, the one you're getting out of. But if you are using the default wrapper method, task.run, it has some default parameters into it, then you have like 100% certainty that you are going out of the thread you're on already.
I just hold it using await and just await and
Yeah, but it would be counterproductive because it would block the thread we are trying to save in. So
but
Yeah.
result.
But if it's very short, they will use it just because it's much more expensive to get one new. But it's very rare. I can show you this.
Yeah, it is not a problem to await a task. I agree. Yeah, not just a little bit strange.
Yeah, it's very. You can see it very easily when. Come on. Okay, let it be in here. Nope. Current thread. Was it a name or managed? Okay, it was this one. Sorry. Pick. Let's say 1. Right now we should have the same thread ID in here. Or maybe because of console application we don't have to. Because of the console application we don't have to. But if you would use normal application with the synchronization context, it would figure out that it's not efficient enough, because here what happens is that he doesn't even bother. He switches every single task to a new thread, and the thread with the ID 1 doesn't exist anymore for him to execution. But it's only because it's console application. You would have to do this on some synchronization context-based framework. But it would work the way that you will have the same thread ID if the await would be short enough. And most of the time, it doesn't bother, it just throws you to another thread. But very, very rare case scenarios, for example, Jitter can figure it out that the lines of code you're executing are not long enough. After a few executions, it's just so clever that, well, let's throw it in here. But it's very rare. For most of the time, it happens when you're using IO bound, task.delay method. That's the most common case scenario.
So you're using asynchronous main method of control application. It's something new in .NET Core. It wasn't possible in previous .NET frameworks, was it?
It's possible since C#.6 or 7 that you
7.1.
was 7.1, something like that. There was an update. Basically, what they do beneath is just decompose it into get-await or get-result method. So you could do do the same. They are creating another instance of a program class, and you can decompile it and see it. Yeah, but in the newer C# you are able to use async main. And what's more, if you are trying to create async void main, console app with async void, it will yell at you that, hey, come on, you can use task. Come on, mate, what you doing here? Some other questions? Okay, so thank you very much. Here's my GitHub account with this presentation and demos you saw. There's lack of the bonus. I can put it there, but I don't know if you want to be able to you know, being the most hated person in the room. Thank you very much. Once again, thank you, Jakub, for letting me be here, for sharing my, let's say, knowledge. I hope that you will play around with TPL and you are not afraid of asynchronous programming patterns, because it's not, well, TPL is so simple. I mean, really, so simple. Magnificent. Thank you very much.